All right, how'd it go? Okay, yeah, it's fine. All right, is that, all right. All right, so let's look at 10.1. Rectangular coordinate system. About to switch pages. That's the title. Rectangular coordinate system. All right, so let's go here. All right, so let me erase. This is 10.1 for us. We're looking at starting off with graphing. And so that's the coordinate system that we're going to use, the rectangular coordinate system or the Cartesian coordinate plane. Both of them are the same thing, just different names. So when you look at this Cartesian coordinate plane, or like I said, the rectangular coordinate system, you have two axes. You have your x-axis, which is your horizontal axis, and you have your y-axis, which is your vertical axis. Where they intersect is your origin. Coordinates of your origin will always be 0, 0. To the right of your origin, positive values. To the left of your origin, negative values. Above your origin, positive values. Below your origin, negative values. Split into 4 quadrants going counterclockwise. Quadrant 1, 2, 3, and 4. To get into quadrant 1, you have to make 2 positive moves. Quadrant 2, you have to go negative and then positive. Quadrant 3, 2 negative moves, and then quadrant 4, positive, and then negative. Then we'll be graphing by what we call ordered pairs. Called ordered pairs because the order matters. It's always your X move first, then your Y. So your horizontal move and then your vertical move. You think about you would run and then jump, or walk, then go down in the elevator, whichever way makes you feel more comfortable with remembering. X comes before Y, in the alphabet. All right, good. All right, so let's graph a few points just to make sure we're okay. I'm going to erase some of this stuff just so we can walk through it. Let's erase this. Leave the points. All right, so we have these 6 points that we're going to graph them. All right, so the first point, 2, 5. You always start your origin. Origin is right here in the middle where your x-axis and y-axis intersect. And so we're gonna start at origin, go to the right 2, and then up 5. So that's gonna be right here. And that will put us in quadrant 1. All right, 2 positive moves puts you in quadrant 1. Then we have -1, -3. So you start your origin right here in the middle, and you go to the left 1, down 3, which would be right here. So that puts us in quadrant 3. Next one, -4, 2. Go to the left 4, up 2. That'll put us right here, which would be quadrant 2. That fourth one, I'll go to the right 1, down 5, and that'll put us right here. And that will be quadrant 4. So before we go to those last 2 points, problems with the first 4. All right. So we have 3, 0. For 3, 0, you would go to the right 3, but then you wouldn't move because of 0. So that'll put us right here. And that wouldn't be in a quadrant. That would be considered on the x-axis. And then similarly with 0, 3, you don't move to the left or right because x is 0. So you just go up 3. And that'll put us in the y-axis. Any problems before we scroll up? Okay, so the next exercise you'll probably see in this section is talking about solutions. Listen, and we talked about solutions before. That was when we had a value that will make a statement true. Well, this time you're going to have an ordered pair that will make your equation true after you plug it in. And so an example of that, if we have 4x, see if I can get my other statement on the right end. There we go. So if we have 4x minus 3y equal to -2, and they wanted to know if 1, 2 was a solution. So don't forget, the first value is always x, second value is always y. That will always be the case. If you have different letters, let's say like M and N, whatever comes first in the alphabet will always be the first value here. And then the second value will be here. So if it's A and B, first value would be A, second value would be B. If it's M and N, first value M, second value N. So it always work that way. It's always according to the alphabet. So that means 1 is going to be x, 2 is going to be y. Plug it in right here. That's 4 times 1 minus 3 times 2 equal to -2. 4 times 1 is 4. 3 times 2 is 6. 4 minus 6 is -2. And so that creates a true statement for us, which is -2 equal to -2. So that means, yes, it is a solution for us. All right. Let's see what we do. So you see the statement right here. Every solution is a point on the line. So every solution represents a point that's on the line. That's how you get your line for all of the values or all of the ordered pairs that are solutions. And that's what that line represents. And so that means there are infinitely many solutions to a linear equation. That line, once again, the line that's created when we start graphing represents all of the solutions for that equation. All right. Any question for us? Scroll up. Still see writing. All right, we good. So let's try it one more time, make sure we're okay. Here we have y equal to negative, I said negative, y equal to 3x minus 5. And they give us two different points to try to see if they are solutions. We have 2, 3, and then 3, 4. So we plug each one of them or each set in individually. And so I already walked through the process in each case, but let's do it. Let's talk it through. So our equation is y equal to 3x minus 5. So for the first order pair, we have 2, 3. That means x is 2, y is 3, and we plug those in accordingly. So that's 3 equal to 3 times 2 minus 5. 3 times 2 is 6. 6 minus 5 is 1. So 3 equal to 1 is not a true statement. So it means it's not a solution. So the ordered pair of 2, 3 is not a solution. Now looking at the ordered pair of 3, 4, plug them in the same fashion. 3 is x, 4 is y. 3 times 3 is 9. 9 minus 5 is 4. So then we have the statement of 4 equal to 4, which is true. So that means 3, 4, the ordered pair of 3, 4 is a solution. All right. Any questions? Any questions? Make sure we're all right. Oh, there it goes. I scroll up. Okay. Let me see. I can erase some of the stuff. All right. So graphing your linear equations. Just holding on to these sections just in case I need them later. It's from the last book we used. But the transition was, I don't know. That's the only reason I'm leaving that right there. But that has nothing to do with you. Anyway, 10-1, 10-2, and 10-2 is I said yeah. For these three methods, those are the sections that they're pulling on. So when it comes to graphing linear equations, you can either use the XY chart, you can either use your intercepts, or you can use your slopes. We're going to go through all three of them, of course, but just the sections in which you will see them show up. I thought for sure that was 10-3, but graphing linear equations, slope, 10-2. All right, well, let me switch that up. Let's do this. I don't know, 10-2, 10-3, 10-4. What if I had 10-1, 10-2, 10-2? That must have been from another book. I don't know. I don't know what's going on. Anyway, that's what it is. It's 10-2, 10-3, and then 10-4. That'll work. Because then 10-5 is parallel lines. Yep. Okay. That works. Check that. So, okay. 6 parallel lines. Okay, just want to make sure still in the same spot since my sections have changed. I don't know. Sometimes with Math Lab they switch stuff up, so I don't know if it's me or if it's something they switch. Anyway, so for us now this semester, 10-2, 10-3, 10-4. All right. So let's look at the first method. XY chart. So we're going to create an XY chart that will help us to graph. So we have our line y equal to 2x plus 1. I'm going to erase this stuff because I'm going to walk through it. And once we walk through it, then I can go back to the. All right. So when it comes to creating the XY chart, they'll give you the equation, of course, and then you choose whatever X values you want to use. In MATLAB, you can only graph 2 points. I have a habit of doing 3 just because back in the day when we did it, we always had three. We always did 3 points. They would do a system of checks. You mess up on one, you know, if you getting 3 points wherein you got a dot, 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 it's like a triangle. Like I said, it's created a system of checks for us. So we always did 3 because we always had to do everything by hand. MATLAB, you only have to do 2 points. But I'm going to stick with my 3 because that's just how, you know, I'm just programmed that way. So now you don't have to do -1, 0, 1, but you do want to choose something easy because whatever you choose, you're gonna have to graph that. So if you want to do, if you don't want to mess with negatives, you want to do 1, 2, 3, it's fine. Just remember you want to choose something that you can graph. If they give you a scale of 10, -10, +10, -10, +10, as far as your graph, can't go over 10. You know what I mean? So yeah, so you just got to make sure that whatever you choose, you can graph. I like to choose -1, 0, and 1. And then from there, you're going to plug it into your equation for x, find the corresponding y value. So 2 times -1 plus 1, that'll be -2 plus 1. -2 plus 1 is -1. So just so happens that -1, when you plug in -1, you get out -1. Of course, that won't always be the case, but they do the same thing for the other 2 values. Plugging in 0, 2 times 0, 0. 0 plus 1 is 1. Then for the last one, plugging in +1, give us 3. Give you guys a chance to write before we look at graphing. Excuse me. So once you have your points, you can go ahead and graph it. You just graph according to the way we talked about graphing points before. I have -1, 1, -1, -1. So I go to the left one, down 1, which is this point right here. 0, 1, you don't go to the left or right for x, but then you just go up 1, which is right here. And then you go to the right 1, up 3, which is this point right here. Once you have your points, you go to connect the dots. So remember I mentioned that it didn't matter what points you choose, just got to remember whatever you choose, you're gonna have to graph. Reason being is if you notice I put arrows at the end of my line, that means it goes on to infinity in those directions. So if you were to choose a point, you know, +100, it'll be way over here, but it will create a point that's way up here that still will connect with the line here. Same thing with something negative, it will choose a point that's way down there, but still connect with the line. So that's why it doesn't matter what points you choose, it will still generate the same line. As long as you stay correct with your mathematics. Only problem is that whatever you choose, you have to graph. So you just gotta make sure you stay on scale. So, all right. So let's look at another problem like this, and then we'll look at another method. Now, when we didn't have a fraction involved, we could choose whatever we want. Here we have a fraction involved. We have -3/5x. I said -3/5x. Y equal to -3/5 x plus 2. So you do want to be strategic here because you don't want to have to grab decimals or fractions if you don't have to. So what values you choose will be dependent upon what type of what your denominator is. Here we have 5 as our denominator. So I'm going to choose, you see my red statement, multiples of my denominator. That means I'm going to choose multiples of 5. So that means numbers that the denominator can divide into evenly. So we're talking about multiples of 5, 10, 15, 20, 25, 30. All, we know the numbers, right? So anything that 5 can divide into evenly. If there was a 7 down there, then anything 7 can divide into evenly. 11, anything 11 can divide into evenly. So those are the values you would choose if you have a fraction involved. So notice the values I chose, -5, 0, and 5. All right. Once you choose your values, you plug them in accordingly. So remember, this at this point, until you walk through it, this is all you have is -5, 0, and 5 for x. Plugging in -5 in for x, we have -3/5 times -5 plus 2. You could cancel out first, or you can just multiply across. This depends on how you normally deal with your fractions. It's up to you. Either way, you still get the same answer. I went ahead and just multiplied across. So that's how I got 15 over 5 plus 2. And then 15 over 5 is 3. 3 plus 2 is 5. So that's how we got the first y value. So do the same thing for 0. 3/5 times 0 is 0. 0 plus 2 is 2. So 0 is always a good option, good easy option. 0 will always cancel out the numbers being multiplied 2. And then last one, of course, if I scroll up too far, let me know. I'm gonna plug up. Hold on, I'm gonna scroll up some. Oh no, what happened? Okay. Move this up some. Yeah. So then plugging in +5 is -15 over 5. That'd be -3 plus 2 is -1. So once you have your 3 points, then you go ahead and graph and connect your dots. Copy. Very good. Sorry about that. Any questions on the first method before we go to the next one? Very good. So the next method is graphing by using your intercepts. So your intercepts are places that the graph actually intercepts the x and y axis. So your x-intercept will be where the graph intercepts the x-axis. The y-intercept will be where the graph intercepts the y-axis. So each x-intercept has a specific characteristic. Each y-intercept has a specific characteristic. All x-intercepts, for all x-intercepts, y is always 0. For all y-intercepts, x is always 0. So you always be able to find it, find your x-intercept by first letting y be equal to 0. You always be able to find each y-intercept by first letting x be equal to 0. And then we can calculate from there. All right, scroll up, everybody good. So let's look at graph and use the intercepts. Let me erase this stuff. Oh, I got doubled like that. All right. Let's see there. Oh, guess I gotta stand on that. There we go. Okay, so first equation, 2x plus 3y equal to 12. Normally, using your intercepts, the best method, best time to use this method is when these two numbers that sit in front of x and y can actually divide into this number over here. So, because that's what's gonna most definitely end up happening. So it doesn't matter which one you find first, whether it be x-intercept first or your y-intercept first. As long as you hold true to what the process is, you still get the same two answers. So once again, I like to find x-intercept first. So going back to your x-intercept, once again, the characteristic of all x-intercepts is that y is equal to 0. So you go ahead and start there. So you plug in 0 for y. 3 times 0 is 0. And that'll leave you with 2x equal to 12. Divide both sides by 2. X is equal to 6. Right. So your ordered pair is 6, 0. Remember, x is 6 and y is 0. Then for your y-intercept, you let x be equal to 0. So 2 times 0 is 0. That leaves you with 3y equal to 12. Divide both sides by 3. 3's canceled. 12 divided by 3 is 4. Ordered pair here, be careful. X is 0, so that means the 0 has to come first. So that's 3, 0, 4. So one of your classmates trying to get in. That's still right. Okay, cool. Oh yeah, gotta graph it right. So then you take those 2 points. Got to do that. Okay, take your 2 points and go ahead and graph them, and that'll give you a line. 0460. Connect your dots. All right. Problem before we try it again. Make sure we're good. All right. So let's do it one more time. Make sure we're all right. So this time we have 5x minus 4y equal to 20. So same process. We have x-intercept. If we're going to find our x-intercept, we start off by letting y be equal to 0. So let y be equal to 0, plugging in 0 for that y. That's 4 times 0, which cancels out, of course. 4 times 0 is 0. That leaves us with 5x equal to 20. Divide both sides by 5. 5's cancel. X is equal to 4. Ordered pairs 4, 0. Then to find your y-intercept, we let x be equal to 0. 5 times 0 is 0, leaving us with negative 4y equal to 20. Make sure you don't lose that negative. That's a minus 4y, so that minus or that negative needs to stay attached to your 4. Then divide both sides by negative 4. And 20 divided by negative 4 is negative 5. So ordered pair here is 0, negative 5. All right, any problems, any problems? Once you have your 2 points, remember that's all we need for Math Lab. You got your 2 points, 4, 0, 0, negative 5. Go to the right 4. That gives us 4, 0. Go down 5, 0, negative 5. And connect your dots. All right, any questions before I scroll up? Any problems? All right, I can scroll up. Everybody okay? All right. So before we go into slopes, let's look at horizontal lines and vertical lines. Thank you, thank you. All right, so notice we look at our equations up to this point, they had x and y involved, all right? So now when you get to an equation and there's just a y, that's going to be a horizontal line. In this case, we have y equal to 5. So that means y is always going to be 5, and x can be anything. So whenever you have these type of situations where there's horizontal or vertical, no calculation is involved, just observation. Once again, you have y equal to 5. That means y is always going to be 5, and x can be anything. So notice when I look at my XY chart, I let x just be negative 1, 0, 1. Does not matter what I let x be equal to, but y is going to always be 5. And notice if you go to the left one up 5, that's this point. 0, 5 is this point, and then to the right one up 5 is this point right here. And you get your horizontal line at 5. All right. Questions on horizontal lines. Make sure we're okay. And vertical lines the same way, except you have x equal to a number. In this case, we have x equal to negative 2. So this means x is always going to be negative 2, and y can be anything. So that's reflected right here in my XY chart. So I have negative 2 for x, and then y, I call it the 1, 2, 3. And so if you were to graph that, you go to the left 2, up 1, to the left 2, up 2, and then to the left 2, up 3. That gives us a vertical line at negative 2. Any questions? Questions on it? All right, so one more thing today. Looking at our slopes. And that's coming out of 10-4. Remember, intercepts with 10-3. Slopes coming out of 10-4, section 10-4. All right, so slopes. M is going to be the letter that we use to represent our slopes. All right, somebody loud a little bit. So we're going to use M to represent slopes for us. Couldn't use S because it's used in multiple places in physics and in mathematics, whether it be speed, hey, S is for something else too. Anyway, it doesn't matter. It's just we're not using it for slopes. So just that's M. So it's going to be y2 minus y1 over x2 minus x1, or y1 minus y2 over x1 minus x2. Either way, it still give you the same result, as long as you remember that if you use y1, y2 first on top, make sure you use x2 first down bottom, or y1 first, make sure you use x1 first down bottom. Elaborate on that more in a second. But then also when it comes to graphing, we're going to use the application of rise over run. And once again, we'll get to that. So x1, y1, and x2, y2 are just any 2 points on the line. So any 2 points on the line will give you the slope of the line. And the slope is exactly what it sounds like. When you talk about the slope of a mountain or the slope of a roof or the slope of a ramp, you talk about the incline or steepness. This puts the numerical value to it. And it actually gives you direction and all of this stuff like that. So there's information in your slope. All right. And scroll up. All right. So they give us 2 points and they ask us to find the slope. Now these would be 2 points on the same line. And you want to know what's the slope of this line. So we have -2, -4, 3, -5. And I always say it's good to go ahead and label and establish which point you call them point one, which one you call them point two. Normally I just call the first one I see point one, the second one I see point two. It doesn't matter which one you call which, as long as you stay consistent in your labeling throughout the process. So x1, y1 would be considered point one, x2, y2 would be considered point two. And if you go back to the formula, remember I said that you can do it either way and get the same answer. So for this first one, I'm going to do both ways, show you that it'll work either way. Then from there, of course, all you have to do is do it once. You still get the same result. But let's look at the first way, y2 minus y1 over x2 minus x1. So when we have this set up, y2 is -5. Y1 is -4, so that's -5 minus -4. So be careful here, make sure you don't lose a negative. There's a minus sign in the formula, but then there's also a negative that's associated with that -4. A lot of times people will lose a negative, just make sure you're careful with that. And then down bottom, circles back. All right, so then down bottom we have x2, which is 3. And then x1, which is -2. Once again, don't lose that negative. Negative to a negative turns positive, so that'd be -5 plus 4, 3 plus 2. And the result would be -1 over 5. And you would leave it in fractional form. Leave it in fractional form, do not convert to a decimal. You are expected to reduce if possible, but you would leave it in fractional form. Don't forget, reducing just means that if you have 6 over 8, it can be reduced by 2, and that'll be 3 over 4. So that's what we're talking about when we reduce. All right. So now going the other way, just wanted to show once again that you can do y1 minus y2 over x1 minus x2. Just be consistent in how you're starting off. Y1 first, x1 first. And so that'd be -4 minus 5 over -2 minus 3. And that'll ultimately give us 1 over -5. And that is the same thing as -1/5. All right. Any problem before we try it again? Make sure we're okay. All right. So here we have 5, -6, 8, 3. Anyway, I call the first point x 5, -6, second point 8, 3. So y2 is going to be 3. Y1 is -6. X2 is 8. X1 is 5. So that gives us 9 over 3 as our fraction. And then that reduces down to this 3. All right. Any questions? Any questions? Mhm. So before we look at graphing with the slopes have four basic behaviors. Mhm. So always reading your graph or your line from left to right. You're always going from left to right. If it's going up, that means your slope is positive. If it's going down, that means your slope is negative. Horizontal line, your slope is 0. Vertical lines, your slope is undefined. And that will always be the case for all four of those scenarios. Once again, reading your graph from left to right, if your line is going up, your slope is positive. If your line is going down, your slope is negative. If it's horizontal line, your slope is 0. If it's a vertical line, your slope is undefined. Okay. All right. Everybody good? Hold on, parallel lines. I believe that's in another section. I might want to hold off on that. Make sure. Okay, parallel, perpendicular. Yeah, okay, no, we're fine. All right, so they just talk about the difference between the two. So parallel lines. If we have two lines that are parallel, we know that they never touch or cross. That means they have to have the same incline, which means they have to have the same slope. So that's the key thing here, that parallel lines will always have the same slope. Perpendicular lines, when they intersect, they create a 90-degree angle. And these slopes are going to be negative reciprocals of each other. So I'm gonna show you what that means in a second. We'll give you everybody a chance to write first. So parallel lines, the slopes will be the same. Perpendicular lines, the slopes will be negative reciprocals of each other. Very good. Now let's look at what it means to be a negative reciprocal for perpendicular lines. So if it's a reciprocal, all we're talking about is flipping your fraction. So that's what we're looking at over here. Oh no, okay. Right here, all we're talking about is flipping your fraction. So it's 4/5. Flip fraction is 5/4. Negative 10 over 7, that's negative 7 over 10. Then 8, if you ever flip that, that's 1 over 8. But if you're talking about negative reciprocals, that means you're talking about opposite signs as well. So you see my little green statement here, you're going to flip the fraction and use the opposite sign. So if you have 4/5, that would be negative 5/4. Negative 10 over 7 would be positive 7 over 10, and then 8, you turn that into negative 1 over 8. So that's what it means to be negative reciprocal. That means you're going to flip the fraction and use the opposite sign. So once again, for parallel lines, the slopes will be the same. For perpendicular lines, the slopes will be negative reciprocals. So that means you will flip the fraction and use the opposite sign. Can I scroll up? All right, let me do this. So get the slope of the line parallel and perpendicular to the given slope. All right. So next exercise. They may ask you, is the given slopes parallel, perpendicular, neither, or they may ask you along these lines, you know, if you have a slope, what's the line, what's the slope of the line that's parallel to it, what's the slope of the line that's perpendicular to it. And so either way, you should be able to, you know, answer accordingly. So they give us 3/5, and they want you to establish what is a line, what is the slope of the line that's parallel to it. Well, if it's parallel, we just finished talking about how the fact that if it's parallel, it's going to have the same incline. That means it's going to have the same slope. So 3/5 is going to be the slope of a line that's parallel to a line that has a slope of 3/5. Now perpendicular, remember, it has to be the negative reciprocal. So that means you're going to flip the fraction, use the opposite sign. So if 3/5 is our original slope, that means I need to use negative 5/3. Then here we have negative 11 over 9. Same thought process. If it's parallel, going to be the same slope. But if it's perpendicular, you flip the fraction and use the opposite sign. So that's going to be positive 9 over 11. All right. And then just one more. If I have 1/7, that's my original slope. Parallel line will have a slope of 1/7. And then you flip that, use the opposite sign, that'll be -7/1, which is just -7. All right, any problems with any of that? Make sure we're okay. All right, the last piece to this slope, usage. So we're okay, scrolling up. All right. Remember I said in the last part of your slope relationship, we have rise over run. So we will use that in order to help us to graph using our slopes. So your rise means the up or down movement. Your run is right or left. Now, what dictates whether we go up or down, left or right, are basically whether we have a positive number or a negative number sitting in the numerator versus the denominator. And so our positive moves will be up and right, negative moves down and left. So for an example, if I have +3 over +4, that means I would go up 3, right 4. Both of them are positive numbers. So we're going to do positive moves. It's rise over run. Top numbers either up or down, bottom numbers left or right. So I'm going to go up 3 and right 4. I have -5 over 7. I normally say just give the negative to the top number, but you could give it to the bottom. But what you cannot do is give it to the top and bottom. Negative or negative is positive, so that negative only goes to one or the other. You just have to make sure which one you're going to choose. Either way, you will get the same line. So if you do -5 over +7, that will be down 5, right 7. But if you do +5 over -7, that's up 5, left 7. So look at it right here. If I go up 5, left 7, that puts me over here. If I go down 5, right 7, that puts me here. But either way, they'll still give me that same line if you do it right. So that's why I say it doesn't matter which one you choose. Just have to make sure that you only give the negative to the top or the bottom, not both. All right. Questions? Any questions before we use it? All right. So this slope-intercept form is going to help us to be able to graph using our slopes. If we have our equation solved for y equal to mx plus b is the form, that means whatever's sitting in front of x is your slope. Whatever's attached to x is your slope. And then the other number is your y-intercept. So if I have y equal to 2/3 x plus 1, that means that 2/3 is my slope and the other number is my y-intercept. All right. Then here another example of that. 5 negative 8 over 13x minus 5. That's equal to y. M is equal to negative 8 over 13. And my y-intercept is negative 5. All right. Okay. So graphing using our slopes, we're going to plot the y-intercept first. And I'll try to emphasize the first on that because that's where you're going. You need a point in order to be able to generate another point using the slope. Remember, your slope is not going to be a point, it's a set of information. Remember, you go up 3, right 4. That's a piece of information. You need a point already on your graph in order to establish another point. So you're going to graph your y-intercept first, and then from your y-intercept, use that information that the slope gave to generate another point. All right, good. So let's try it out. So if I have y equal to 2/3 x minus 1, so look at the information that you can pull from that equation. Your slope is 2/3, and your y-intercept is -1. So we have a positive 2 over positive 3. That means I'm going up 2, right 3. Those are both positive moves. Remember, that's just a set of directions. Now, when it comes to my y-intercept, don't forget we talked about intercepts earlier in this class. If it's your y-intercept, x is always 0. So that's going to always be your coordinate. 0, and then whatever number you get, or whatever number you have. In this case, is -1. So 0, -1. All right. Everybody okay? So we graph that y-intercept first, which is right here, 0, -1. You don't go anywhere for x, we just go down 1. Then from the y-intercept, you start right here, and then you go up 2, right 3, and that'll give us our other point. And that'll give us our other point on the line. And that's how you use your slope to graph. All right. Questions on that one before we do another one? Just want to make sure we're okay with what we did. All right. Are you okay to do it again? All right. So next one, we have -1/4 x plus 3 is equal to y. So once again, when your equation is in this format, y equal to whatever your value, whatever your equation is, the number that's attached to x is your slope. The other number that's separated from your x is your y-intercept. So here, -1/4 x. So that means -1/4 is your slope. And then 3 is going to be the y-intercept. So -1/4, that means -1 over +4. I go down 1, right 4. And then if my y-intercept is 3, my ordered pair is 0, 3. So you grab 0, 3 first. You don't go left or right because x is 0. We just go up 3, which is right here. And then you go down 1, right 4. And that's your line. Thank you, dots. Questions? Any questions? We can do one more. So notice in these last two, our equation was already solved for y. If your equation is not solved for y, it would be in your best interest to go ahead and do so. So if I have 5x plus 2y equal to 8, and I want to solve my equation for y so I can put it in the format that we just had, I will subtract 5x from both sides. That'll leave me with 2y equal to -5x plus 8. Then divide both sides by 2. Don't forget that 2 needs to go into both terms in the numerator. And so that'll give me -5x plus 4. So once you solved it for y, we can go ahead and pull the information like we did the previous problems. The number is attached to x, or sitting in front of x is your slope, so it's -5/2. The other number is your y-intercept. So we have -5 over +2. So that's down 5, right 2. Then we have the ordered pair of 0, 4 for our y-intercept. And then same procedure to graph your ordered pair first, which is 4, 0. And then from that 4, 0, you go down 5 and then right 2. All right, any problems, any problems? Okay. So that's graphing. It's 10-1 through 10-4, just graphing. Remember, every day is opportunity for questions if you have them. So make sure you guys are getting into Math Lab, trying stuff out, see if you have any issues with any of these problems. And we'll go from there. Once again, next class, I'll open up the floor for questions, just like I did this class, see if anybody have any. And then, yeah, that's how we operate. And let me see. No, I'll save that for next class. Never mind, I'll save that for next class. Okay, so any questions before we close out? As far as the lecture is concerned, any questions? Everybody good? Everybody straight?
I'm just having problems with the math lab. I guess we could talk after.
Mm-hmm. All right, everybody else straight. All right. So if you guys are good, I'm good. Have a good day, be safe, and well, yeah, shoot, that's a good weekend, right? Yeah. Have a great weekend. And I'll see you guys on Monday.